Hi, everyone. So I wanted to do a quick quiz review for you because we're not going to really have time in class. It was evident on this quiz that while you've mastered the concepts you've learned in our class, your work from Algebra 1 on the laws of exponents, some of you need to go back to this topic. It's a basic topic, but it's been a while. So I did review it at the beginning and I gave you some supporting videos, but they may be worthwhile as well. But in order for roots and radicals and rational exponents to be easier, your rules of exponents need to be like really good. So you have to know that if you have two variables, like x cubed and x to the fourth, where the bases are the same, this only works when the bases are the same, and if it's multiplication, then you add the powers. Power times a power, add them high. The same would be true if the radicals have fractions, but then you'd need a common denominator. That's what we've been working on. Okay, if I have a power raised to a power like this, then we multiply the exponents. Again, these two rules you learned in Algebra 1. All right, then we've got power divided by a power, so something like this. And my rule is bring the smaller exponent to the larger exponent and subtract them. So, let me redo that. So that would be the smaller is in the numerator. So I'd have to leave a placeholder 1, and that would be 5 minus 4, so 1 over x. All right, what happens if the exponents are negative? Well, the basic rules of negative exponents, number one, are if I have x to the negative 3, you can rewrite this as 1 all over x cubed. Now, if I have x squared over y squared, say to the negative 2 power, the easiest way to do this is to first flip your fraction, y squared, x squared, and make the exponent positive. Basically, that's what would happen if you distributed it through and then flipped it, you'd be in the same place. So I always say flip the fraction and make the outer exponent positive, then simplify. All right, now, these are the basic laws of exponents. Now, what happens if I give you, say, x to the 7th all over x to the negative 3? Well, you still bring the smaller to the larger and subtract, but that's going to become x to the 7 minus negative 3, so x to the 7 plus 3, which would be x to the 10. Again, smaller to the larger and subtract. All right, so now let's look at your quiz. You all did great until we got to number 7. That's where I started to see some problems. If you made a mistake earlier, it really was those numbers we keep talking about. You're going to have to know, like 3 cubed, 4 to the 3 power, because without a calculator, you're going to need to be able to evaluate them. All right, so when we're looking at the roots like this, you don't want to immediately rationalize. That's like our last step. So the first thing that I want you to say to yourself is, okay, can I simplify? So that would be step 1. Can I simplify? Okay, actually, let me move that down to the bottom. Okay, can I simplify? All right, so yes, you can, because remember, another way to think about this is this. It means the exact same thing. Okay, so that means we bring the smaller to the larger and subtract. And so that's going to give me the cubed root of 81, x to the 3rd, y to the 6th. Now, I love that because those numbers are now pretty. Okay, all right, now I have to break up the cubed root of 81. So I do need to know my cubes. So 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. Okay, well, 8 doesn't go into 81, and 64 is too big as a factor of 81, but 27 is a factor of 81. 81 is 27 times 3. So then you can evaluate it. So the cubed root of 27 would be 3. The cubed root of x cubed would be x, and the cubed root of y to the 6th would be y squared. But you'd still have this 3 left over. And that would be your answer. So I want you to look at your work and actually ask yourself, what did you do? A lot of you tried to rationalize this first, and I said, really, you want to rationalize as a last resort. Simplify, simplify, simplify. So really, that was a 2-step question. All right, let's keep looking. All right, this one gave us some trouble, and this is really just basics power of exponents, but it's got fractions. Now, you also have to remember that if a question asks you to simplify and they're variables with rational exponents or fractional exponents, leave them as fractional exponents. So don't feel like you have to turn it into a root. Well, we know 3 to the 0 is 1, so that was just me asking you, do you know that rule? I have x to the 1/2, and then I have power times a power, so I'm going to multiply the exponents, and that's going to give me x to the 1/12. Now I have power times a power, so we have to add the exponents. So 1/2 plus 1/12. All right, common denominator would be 12, so I would multiply this by 6/6. So I get x to the 6/12 plus 1/12, which is x to the 7/12. And because I started with rational exponents, my answer is going to be left in rational exponents. I would turn it into roots if it wasn't a variable and it was a number, because then I might be able to evaluate it, okay? All right, number 9, a little bit harder, but got to use those rules. So I'm going to highlight here. So you could simplify first if you wanted to. You could simplify those guys first and then flip, okay? Or you could flip the fraction and make the outer exponent positive. It really kind of is up to you. I simplified first inside the parentheses because I wanted to follow order of operations. So 3/5 is bigger than 1/2, so I brought that down, and that would have been x to the 3/5 minus 1/2. Now, I did go over to the side and do 3/5 minus 1/2. My common denominator would be 10. And so this would be 6/10 and 5/10, which would be 1/10. Okay. All right, this was a little bit trickier because y to the negative 1/6 is actually bigger than negative the 1/4, because on the number line, negative 1/4 would be farther left. So I brought the 1/4 down. So that would have been negative 1/6 minus negative 1/4, giving me plus 1/4. Okay, so I went over to the side and I did negative 1/6 plus 1/4. My common denominator was 12. So that would have been negative 2/12 plus 3/12, which would give me 1/12. So I'd have had y to the 1/12. So that would have left a placeholder 1 in the top. Now I have this outer exponent of 2. So I would flip and make it positive. So that would give me x to the 1/10, y to the 1/12 squared. So power times a power, add them high. So that would be 1/10, and power to a power multiply. 1/10 times 2, which is 1/5, and 1/12 times 2, which would be 1/6. So x to the 1/5, y to the 1/6. That took a lot, right? It took some work. You could have flipped at the beginning though as well and flipped them and made them positive, made the outer exponent positive. You wouldn't change the y to the negative 1/6 and y to the negative 1/4 when you flip them. And you should have gotten the same answer. A lot of the mistakes I saw were when you squared it here, you said this was 5 and 6. So maybe rushing. Some of you didn't change this to positive. Some of you didn't find common denominators. So I would take a really good look at number 9. Maybe try it again on your own. All right, number 10. Okay, so number 10 was where we started to get into, you maybe have to rationalize. So first I'm going to see if I can simplify anything, and I can. You can see the x would simplify with the x. So that would give me the cubed root of 3 all over the cubed root of 2y to the 4th. All right, so I can't simplify anymore, so now I do have to rationalize. But rationalizing is not the same as it is with square roots. Square roots, we just multiply by the same denominator over the same denominator. And that's because square roots, you need 2 of whatever you're going to multiply because you need a real number in the bottom. When it's cubed roots or fourth roots, you need the number of times the root. So here, I have 1 2. I need 3 2's. So I'm going to have to multiply by the cubed root of 2 squared, which is 4. I have 4 y's, but I'm going to have to get to something that's divisible by 3, which would be 6. So I need 2 more y's. And that would be how I determine what I'm using to rationalize. Okay, so now let's see what happens. I multiply across and I get the cubed root of 12y squared. I cannot simplify that because 12 and y squared are not roots. In the bottom, I'm going to get the cubed root of 8y to the 6th, which is going to give me or evaluate to a real number. So my final answer, the cubed root of 12y squared all over 2y squared. Again, the role of rationalizing a denominator is to get a real number in the denominator. So you're trying to, in this case, get the bottom to be a perfect cube. Okay, hopefully that was helpful. All right, this one. I think what many people didn't really notice on it, if you got it wrong, was it's subtraction. And remember, with subtraction, if I gave you like 2 root x plus 3 root x, these need to be the same. So they act like terms, so that would give me 5 root x. On the review, we spent some time recognizing that sometimes you have to simplify first. So we have to simplify all of our roots. And I think some of you just jumped to rationalization, not with 300 and 108 and not a calculator. So first I simplify 4 and 300. So that would be 4 times 300 would be the square root of 100 times the square root of 3, which would be times 10 root 3. 108, okay, 9 goes into 108, so I'm going to check 36. That's our rule. So this would be the square root of 36 times the square root of 3. This guy kind of helped me recognize that 3 might go into 108. So that would be 6 root 3. And then the bottom, root 12, simplifies with 4 and 3. So that would be 2 root 3. All right, now we do our multiplication. So 40 root 3 minus 6 root 3 all over 2 root 3. All right, so that's going to give me 34 root 3 divided by 2 root 3. All right, now here, these roots can actually cancel, and 2 does go into 34 17 times. So my answer would have been the real number, 17. All right, I really appreciate your patience. Again, if you got it right, you can skip through, but maybe you might be watching this just to help yourself a little bit. All right, and number 12, some of you made this incredibly difficult when this was really a short problem. And you have to be able to do this algebraically. So next time it will say, find all the real solutions using algebra. I love that some of you got creative when you forgot what to do and guessed and checked, and that should always be what you do. But I will be very specific that you're going to have to use this with algebra. Now, when you look at these, you have to actually in your mind say, what is going to be the easiest thing to do with that 2? I do not want to square here because that's going to get really confusing. So the first thing that we talked about doing would be get that 2 to the other side. Okay, so that's going to give me the square root of x minus 2 equals the square root of x minus 8. So anytime there's a expression under the root, I try to get it alone if I can, that x minus 8. Okay, now you square both sides. Okay, when you square the left, it's the square of a binomial, so you do have to FOIL it out. You could use an area model if you want, but you square the first term, you double the inside product, so you double those things multiplied, and then you square the last term. On this side, the square is going to undo the radical, and you're going to just be left with x minus 8. Okay, now what happened here is I saw some of you square this. The goal is to isolate the root in these types of equations. You just have to, you're going to end up squaring twice. So to isolate the root, I subtracted x, and it simplified out. I subtracted 4, and it gave me negative 4 root x equals negative 12. Divide by negative 4. So the square root of x equaled 3. And then you square both sides. So x equals 9. Then you check your answer. The square root of 9, does it equal the square root of 1 plus 2? The square root of 1 is 1 Square root of 9 is 3. The answer works. And if you could help me out by writing check above it so I know that that's what you did, that would be helpful. All right, guys, I hope that was helpful. Review of your quiz. Again, if you need more practice, let me know. You may have seen that I did suggest to a few of you that you go on the new Delta Math program that I'm using, so to get some practice on laws of exponents, okay? Have a great day.